This video is part 1 of 2 for either August 31st, which is an A day, or September 1st, which is a B day. If you're absent, we just need extra clarification. That's what these notes are for. This should be one part of 2, and let's go ahead and do this. So our objectives really for this lesson were to graph and transform the sine and cosine functions. And then we're also going to look at key features, and we'll look at those as we graph. It might be helpful to have a correct unit circle around because we're going to use that. I'm actually going to go through these ordered pairs relatively quickly, so we spend most of the time talking about how the function behaves and the key features. But what we did in class is we're looking at sine of x. So we're replacing values with x. These x values, we're placing those in our function and seeing what we get up. So for example, we said sine of 0. So we look at 0 on our x-axis. On our unit circle, we know that sine is y. And so if we plug 0 in, we get 0 out. And so input was 0, our output was 0, we get 0, 0. Similar thing if we do sine of pi over 6. If you look at your unit circle, sine of pi over 6 is 1/2. So pi over 6 was our input, 1/2 was our output. And we can keep going. I would actually suggest pausing it and trying to fill in the rest of the table values on your own. I'm going to go ahead and do that quickly. So if we input pi over 4, if we look at pi over 4, sine would be square root of 2 over 2. At pi over 3, sine is square root of 3 over 2. Pi over 2 is 1. 3 pi over 4 is square root of 2 over 2. At pi, we have 0 again. 3 pi over 2, negative 1, and 2 pi 0. So we have these ordered pairs. Take a second, I would pause it. Let's see what we notice in terms of our largest x value. Oh, wow, sorry. Our largest x value versus our y value. These should be pi, because that was our input. This should be 3 pi over 2, because that was our input, and 2 pi. Now, if you took a pause, that would probably be good. But if we're looking at our largest x value, our smallest was 0, our largest was 2 pi. So I'm going to call this out here 2 pi. And then just scale it. So we know between 2 pi and 0 would just be pi. Between pi and 0 would be pi over 2, or half a pi. Between pi and 2 pi, 3 pi over 2. And between pi over 2 and 0, pi over 4. Let's just look at this for right now. Now let's look at our y-axis though. We also need our y. Our smallest value was negative 1. And our largest value that occurred once was 1. So we call this 1 up here. Negative 1 down here. And let's see what happens. What I talked about, excuse me. Talked about in class is looking at easy points. What are points here that are easy to point? So for example, 0, 0. We know 0, 0 is right here. It's not going to show up very well, but 0, 0 is right there. Pi over 6, 1/2. We could do that. Pi over 6 is going to be less than pi over 4, and 1/2 would be around here. But for example, I'm not going to be concerned about graphing pi over 4 comma square root of 2 over 2. Because that's going to be more difficult. I know pi over 4 is here, but square root of 2 over 2, I'd have to estimate. But we know pi over 2, 1. I can go to pi over 2 and 1, so pi over 2, 1. Pi and 0. 3 pi over 2 and negative 1. And 2 pi and 0. And if we draw a smooth curve connecting these dots, what we end up with is this function. and this would continue on forever in that direction. But between 0 and 2 pi, we have this wave function. And if we continued in forever in the x direction, positive x, it would continue this pattern. It'd go up to 1, down to -1, keep going. Similar if we go in the negative x direction, we can still create some kind of graph that looks like this. Trying to do it to scale. It's a little hard, but that works. Okay, keep going on further. And in class, we actually use symmetry here to kind of look at what our how we could label our x-axis. And so let's start here, where the function is at -1. And what we said is this would be -pi/2. So at -pi/2, the function is -1. Also, if you want to think about coterminal angles, -pi/2 is coterminal with 3pi/2. At 3pi/2, the function is -1. At -pi/2, the function is -1. They're coterminal, they should have the same values. Here at 0, this would be -pi. -3pi/2. Similar story with -3pi/2 and pi/2. And then hopefully you figured out that this point would be on our x-axis -2 pi. So you have this function, we have, it has like a wave shape. It's going to go on forever in both directions. And it's going to continue going up to 1, down to -1, up to 1, down to -1, forever. Now I'm going to go through some key features. I'm going to write those key features here so we can look at the graph while writing these key features. If you want to write in the space below this, that's fine. But in class we said it goes on forever in the x direction in both directions. If we're talking about x and y values that a function takes, we're talking about our domain and our range. Okay. In fact, let me write this in blue ink for the rest of the time. Our domain and range. And so since we said it goes forever in both directions on the x-axis, if it was going forever in the negative direction, we call that negative infinity. And forever in the positive direction, we use positive infinity. Now, we're talking about brackets. These brackets or parentheses. A parentheses means that we can go up to that value but never touch it. A bracket means we go and actually touch that value. So because we cannot touch infinity, we use a soft bracket here to denote our domain. And now our range is the values that y can take. Well, if we look here in the function, the lowest value that y takes is -1. It never goes below -1. And it touches -1. So I can use a hard bracket at -1. And then it goes up and touches at +1 here and there. But it never goes above 1, +1. So our range, or the values that y takes, is from -1 to 1. We also called an amplitude. So if we look at this function, it's a wave function. Let me write this. It's a wave type function, and an amplitude is one way we can kind of measure a wave. And an amplitude is the distance from the middle of our graph, so the middle to the top, or the distance from the middle to the bottom. So this distance here would be 1. This distance here, you might say -1, but we're talking about distance, so that's still 1. So our amplitude here to measure the wave is going to be 1. And then the last thing we notice about this function is it has a period. In math terms, this means that it repeats. And so in class we said, all right, if I start at this point and trace the function, so I'm going to go this way, I go up, down, all of these values are new. I keep going down, and then it goes back up. And then here at 2 pi, it would repeat itself. It would go up again to 1. So it's follow this pattern, go back up, go back down, 2 pi, do the same thing. So because it repeats itself every 2 pi units, we say that this function has a period of 2 pi, or in other words, it repeats itself every 2 pi units. Now, we also talked about even odd. I'm going to get to that in the next section, but these are key features of our sine graph. We have a domain from negative infinity to infinity. We have a range from -1 to 1. Amplitude measures the middle to the highest point, the middle to the bottom point, and then our period. These are key features that we know about this graph. Go to the next video, we'll talk about cosine and those key features, and then definitions of the key features.